Today we are going to introduce an intelligent energy management system, V2G Vehicle to Grid System.
Vehicle to Grid is an application of smart grid, or make it simple, a vehicle connect to power system. The smart grid has power suppliers and power consumers connect to it. Power suppliers are power plants, which is the main power supplier, for example, wind turbines or solar panels. They supply electricity to the grid. Power consumers are like lighting, electronic devices, or battery vehicles. Before the invention of smart grid, all conventional power grid systems have structure like this. At the top level or the center of the conventional grid is the power plant, where the electricity comes from, followed by the transformers, oops, not this one, to increase the voltage to a suitable level for transmission. Then the power is transmitted through high voltage lines. It is for the purpose of reducing waste of power during transmission. Then the user can not use it directly yet. The voltage needs to be decreased for user to use, otherwise it will not be safe. So a high to low transformer is needed. After that, the user can use this power for lighting bulb, watch television, running refrigerator, doing laundry, or charge a battery car. The major problem of conventional grid is the energy production and consumption. An electricity generator can't vary power output during its nature, though the power production capacity of a power plant is hard to vary either. The power requirement of all customers were higher in the daytime while lower at night. Since the output of power supplier is a straight line, at this area, the power output capacity could not meet its requirement. Some of the customers have to be switched off, or the whole power system will fall by a voltage drop. When the power requirement is low, the generated power will not be fully utilized and have to be wasted as heat, which will heat up the power supply system, causing short lifespan. In the smart grid, by this power storage, the line showing power consumption will be flattened. There would be less energy wasted, and energy requirement during peak period will be minimized. And compared to conventional grid, smart grid has advantage in greenness, security, efficiency, survivability, autonomy, and intelligence. So what is a smart grid looks like? A smart grid is a power system can supply and consume power intelligently. One of the important characters of a smart grid is that it decentralizes the power supplier. The supplier of power won't just be the central power plant here, but also some discrete small power sources and storages. These small power sources and storages could form a logically virtual power plant to support consumers. The vehicle to grid is an instance of this kind of power storage system. The power storages could act as a power consumer when capacity of supply is larger than the consumption, and when consumption is larger than the supply, it will act as a supplier. V2G Smart Grid consists of three entities. Central authority, it acts as a trusted entity that belongs to an independent institution. Local aggregators, which are the power and communication service access point. And battery vehicles. Among them, a power link is used to transmit electric energy. Information is exchanged through wireless communication link. In the wireless communication link, different communication solutions may be offered. ZigBee support load control devices and electronic vehicles, as it could provide communications primarily related to efficiency, cost, and messaging. Between stationary BVs, wireless sensor network and vehicular networks can be used to support information changing, and cellular network support long-range communications, making it a good option for highly mobile BVs. In such a system, private information like battery status and BV location could have the potential threats to be captured, deceived, or blocked. If those information is captured, attacker will be able to know BV's radius of movement. The destination of BV is predictable, and attacker could use it to track BVs, which means those vehicles are under the control of attacker. So the major issue of V2G is how to keep so sensitive information secure. Here, we will illustrate a solution for V2G communications in the smart grid. Among those three entities, there are limited security protection resources with battery vehicles and local aggregators, so it won't be safe to allow them to deal with those information. Only central authority has a right to authorize actions and make decisions. Battery vehicles may make a request and accept or refuse decisions, and local aggregators could only forward whatever data it receives to its destination. Furthermore, before and after the transmission, battery vehicles and central authorities will do the encryption and decryption accordingly. In this case, the attacker will have to either brute force those encrypted data or fight with CE's computation power to break the system instead of local aggregators. Since central authority is well equipped with perfect system resource and security strategies, the system is much more unbreakable in terms of security. By research, every battery vehicle will bring electric company about $4,000 of profit. In the near future, electric cars may help to stabilize our power system and reduce our electricity price a lot.